All right, Honors Algebra 2, welcome to your, I believe, what is this, the third video for section 7.5 to 7.7 game plan. Again, you guys were supposed to have viewed this first. Honors Algebra 2, section 7.6 notes. All right, because in that you learn of this right here. And that, and that's what we need to know for this section. So if you didn't watch it, go watch it now. Anyway, there's two different ways to do these questions. I'm going to show you the way you're going to do it in calculus and pre-calculus. All right, I show a different way in regular algebra 2, but I want you to do it the way I show in this game plan. So first off, this one's real easy. You could write it as exponential form. It would, or in logarithmic form. I'm sorry. Log base 7 of the answer 41 equals x. Then you have the change of base. X equals log 41 divided by log 7. Or you can also, and this is what we're going to do here on out, you can attach natural log to both sides. Remember, natural log is log base e. So the power property applies that x would come on down. All right, so we'd have x natural log 7 equals natural log 41. I can divide both sides by natural log of 7. So log 41 divided by log 7, or natural log divided by natural log 41 divided by natural log 7 is, believe it or not, going to give you the same answer, 1.91. All right, so one like number 3, I would attach natural log to both sides. This power would come on down. X natural log 5 equals natural log 55. All right, to get rid of x, I would divide both sides by natural log 5. Now, believe it or not, that is the exact answer. Natural log 55 divided by natural log 5 is how I'm going to want you to write the answer when, hopefully, we meet again one day in calculus. All right, number 4, again, I would attach natural log to both sides. That means the x is going to come on down, and that is just the power property of logarithms. Then you're going to divide both sides by natural log 3. Get natural log 40 divided by natural log 3, 3.38 if you want, but you can just leave it exact. All right, number 6 is where they start to get interesting. Same thing, attach natural log to both sides. Then this x plus 2 comes on down. Write it in parentheses because you're going to divide both sides by that natural log 4. Again, what you guys need to do over this little break is not only write these notes, but keep reviewing them over and over and over. Use them to help you do the quiz reviews. I'm going to probably make the first quiz review video either this weekend or on Monday. All we need is the game plans done this week. You got x plus 2 equals natural log 15 over natural log 4. That's what x plus 2 is, so you're going to subtract 2 from both sides and write it like that. Again, that is the best answer. It's also that if you type everything in. All right, number 7, folks. Attach natural log to both sides, you guessed it. Then that 4x is going to come on down as an exponent. 4x natural log 3 equals natural log 72. Divide both sides by natural log 3. All right. 4x equals, okay, now let's be careful here. Let's look here. If you wanted to, you could divide those, and you get roughly 3.893, and you can divide it by 4. Or, this is going to look more in the calculus style here. I know I'm going to divide both sides by 4, so 4 is going to go in that denominator. This is another way you could write it, and that's the best way. Right here, remember, this is another way to write this. 4 on the outside is really an exponent, so if you wanted to really look impressive, you can write it like that. All right, 8 and 9, you guys are going to try on your own. When I see you again, I'll give you help on those. Or if it's a while, I'll come back and give you help on those, okay? One way or the other, you'll get those answers. Same thing with 10. Let's take a look at 11. Attach natural log to both sides. Then you're going to divide by natural log 2. Add 1 to both sides. And that's the best answer, or that. And lastly, number 12, attach natural log to both sides. Bring down the 3x. Divide both sides by natural log 4. 3x equals natural log 7 divided by natural log 4. Again, you're allowed to use decimals. Round it to 2 decimals, the nearest hundredth. 3x equals 1.404 divided by 3. Again, if you're confused how I'm getting that, there is the natural log button. What we got here? Natural log of 7 divided by natural log 4. Boom. And then that's what 3x equals. You would divide then by 3. There we go. All right. But the best answer, I think, is if you have 3x equals natural log 7 over natural log 4, simply divide both sides by 3. Put the 3 in the denominator. Again, you can write that 3 as an exponent. You can write it as natural log 7 divided by natural log 64. Some harder ones indeed. All right. As you know, so obviously we've already gotten things to be the same base. You cannot get 18 to be 2 to any power. So if that can't happen, you have to attach natural log to both sides. That's why using natural log is so important. Like if this was 8, it'd be no big deal. I would just get 8 to be 2 to the third, and then boom, the powers would be equal. Not this case here. The bases will not be equal. Attach natural log to both sides. X plus 3 is going to come on down. 3x is going to come on down. Now what you have to do here, these will definitely get you ready for pre-calculus. So you have to distribute. That would be x natural log 2 plus 3 natural log 2. What you're going to do, again, this is a hard one not to do in person. What you're going to do is get anything that has an x on one side. So notice how the only term on the right side has an x. That means I'm going to ship this guy to the right. It's positive on the left. It's going to be negative on the right. Notice they both have x's. So what I do is I factor out the x they have in common. Put the x on the outside. That would be 3 natural log 18 minus natural log 2. I'm going to divide both sides by this. Divide both sides by 3 natural log 18 minus natural log 2. That's the numerator, that's the denominator, and that's a good enough answer. All right, so these are definitely more challenging. Probably see more of these in pre-calc. All right, what you're going to do here, attach natural log to both sides, as we did. So the washer is going on in the distance. Hopefully that's not too loud. Going to bring down that 2x. Going to bring down this 4x plus 3. All right, that's just simply going to be 2x natural log 7. 4x would go with the natural log 52. 3 would go with the natural log 52. Anything with an x, I'm going to move over to this side. So it's going to be 2x natural log 7. This was a positive on the right. It's now a negative on the left. Equals 3 natural log 52. They both have x's. Factor out the x. Put it on the outside. 2 natural log 7 minus 4 natural log 52 equals blank. Divide both sides by this. 3 natural log 52 divided by this. Holy cow. All right. 15 is one you'll do on your own eventually. I'll help you with 16, very similar. As I've done, attach natural log to both sides. Again, you can also attach log, all right? A lot of books show natural log, some do log. Does not matter. It's the same power property involved, okay? I just use natural log. Bring down, when you do that, bring down the exponents. Bring down the exponents. That's how we get 3x natural log 11. That's how we get x minus 3 natural log 3. Distribute. Now notice, we'll get some blue in here. On the right side, you just have 3x natural log 11. So you're going to move this over. It's going to be x natural log 3. Put the x on the outside. Factor out the x that is. So 3 natural log 11 minus natural log 3 equals this. Going to divide both sides by 3 natural log 11 minus natural log 3. That is the numerator. That's the denominator. Again, these are definitely more of a challenge. Number 17. Attach natural log to both sides. X minus 3 comes on down. 2x comes on down. Power property. X natural log 5 minus 3 natural log 5 is equal to 2x natural log 11. So, on the right side, I have a term that has x. That means I'm going to move this term over to the right side. It was positive on the left. It's going to be negative on the right. I'm going to factor out the x that they have in common. Put it on the outside, leaving me with 2 natural log 11, or natural log 121, if you want to bring that exponent up, minus natural log 5, which if you wanted to, you could combine them too. That's the quotient property, but that's all right. We can leave our answer like this. All right, on the next page here. All right, we're either going to wait for class or eventually, I really want to do this one in class. If not, I'll help you out here. Anyway, this is how you're able to figure out how much money you can have an account while you also deposit money monthly. This is the goal. Like you put $5,000 into account, and then every month you put in $100. And then after a certain amount of time, so look at this example. $5,000 is deposited into an account at an annual interest rate of 5% compounded monthly with additional deposits of $100 per month, basically at the end of the month. They kind of want to know when you put it in. We'll just say at the end of the month. The value after 10 years. So if I just put this in for 10 years at 5% and I did nothing to it, I would only have $8,144. All right? But and that's like if I get 5% rate of return a year. All right? But after 10 years with depositing $100 a month, that's how much the account could have. So you can see a big difference there. All right? So we'll talk about that one hopefully in class one day soon. All right, Honors Algebra 2, exponential logarithmic assignment. Write each exponential in log form. These are really easy. All right, that's the base, that's the exponent, that's the answer. I feel like you guys can do. I think I gave all the answers for this. Anyway, go ahead and do those. I'll help you out with some of them later on. Then write each exponential function write each logarithmic function in exponential form. I think that is a coffee break with that miss. 2 to the 4th is 16. 3 squared is 9. 4 to the 1/2 is 2. 3 to the negative 4th is 1 over 81. I know I'm skipping some, but these are very, very easy. 5 to the 3rd is 125. And 17 to the 1st is 17. All right. Another review. Here is, you could attach a natural log to both sides, but we're going to get exact answers here. Like 2/3. You can get them to be the same base. So, remember a power to a power. Here, 3x plus 3. This is all review. If the bases are the same, the exponents have to be equal. All right. 125 is 5 to the 3rd. Power to a power, multiply the powers together. 2x minus 1 equals 6. This one, though, a little bit of a challenge. So 49 is 7 squared, and 1/7 is 7 to the negative 1st. So they're both base 7. All right. Bases are the same. Get the exponents to equal each other. Eight over 1. Or 1 over 8, 1 over 64. That's 8 to the negative 1st. That's 8 to the negative 2nd. All right. Set the exponents equal to each other. 64 is 4 to the 3rd. Power to a power time. Exponents are equal. All right. This is a little bit of a tricky one here. 2/3, you can't really do anything with 2/3. So you got to think 2 to the 4th is 16. 3 to the 4th is 81. So 2/3 to the 4th power is, in fact, 61 over 81. Okay, so get them both to be the same base. Base of 2/3, that happens. That would be exponential decay. Power to a power, you multiply the exponents together, then set the exponents equal to each other when the bases are the same. You got the same type of thing on 24. 3 squared is 9. 4 squared is 16. Power to a power time. Multiply the powers together, then set the exponents equal to each other. All right, let's see if we can finish this. Describe each as exponential decay or growth and state the percent growth. Move it over twice, 12% growth. Move it over twice, 6.5% growth. Move it over twice and subtract from 100, 3% decay. Move it over twice, 1.5% growth. Move it over twice, subtract from 100, 12.5% decay. You start running or working at ABC Runco. I believe we've done this one before. 37,000 is what you make year one. And you'll get a sense of something outside. Poorly trained dog, honestly. You will receive a 2.5% increase each year. We're going to pause this for now.